Probability is the likeliness an event will occur. When calculating probabilities, the sample space is called S. The different outcomes are called events and denoted with the letter E. From these possible outcomes, probabilities can be found. To find the outcomes, write down the different ways you can have a family of 3 children with boys and girls. For an answer, you get boy, boy, girl, boy, 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 girl, girl, boy, girl, boy, girl, girl, boy, girl, boy, girl, 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 and girl, boy, boy to give you a total of 8 different outcomes. Now let's try the same problem from before, but this time use the probability formula. You are given the sample space. To find the probability of having all boys, you count the number of outcomes that are all boys, which is 1, and since there are 8 outcomes, the probability is 1/8. When you draw a card from a deck, it is not possible to have drawn a face card and an even number at the same time. Therefore, the events are exclusive. If a card is chosen from a deck of cards and not replaced, and another card is chosen, the probability for the second card is affected because there is one less card in the deck. Here is an example for you to try on your own. Match the terms in the left column to their corresponding event on the right. The answers will be shown at the end of the video. There are 52 cards in a deck, and 12 of which are face cards. Therefore, the probability is 12 over 52. There are 6 numbers to a die, and 3 of which are even. Therefore, the probability is 3/6. You add them together to get a probability of 19/26. Let's use the same example from earlier and find the probability using the sample space. There are 8 outcomes altogether, and 3 of which have 2 boys and 1 girl. So the probability is 3/8. And there is 1 outcome with all girls. Therefore, the probability is 1/8. You multiply them together and get an answer of 3/64. From the problem, you can see the word given, which is a clear indicator that this is a conditional probability. In the numerator, you will have the probability he passes the test and studies, which is 0.78. because that is the probability of the intersecting events. In the denominator, you have the probability he studies, which is 0.82. Simplify the fraction and you have 0.95. Therefore, there's a 95% chance he will pass the test given he studied. Here are practice examples you can try using the formulas you just learned. The answers will be at the end of the video. A treat diagram can be helpful in finding the outcomes of a particular scenario. Organize the data in the problem into a tree diagram like the one below. From looking at the chart, you are able to examine all the different outcomes easily. You can see that there are 12 different combinations below. Expected value can be used to determine how much one can expect to win or lose on average in a game. Expected value equals the summation of the value in the x column in the chart, multiply the value of the p of x column. The values in the x column are what you expect to win or lose in an event, and the value in the p and x column is the probability of that event. Find the expected value, multiply each x by its corresponding probability, and add up the products. Since the answer is negative, you can expect to lose money, and the game would be considered unfair. These are the answers for the problems using addition and multiplication of probabilities and the conditional probability. For more help with probability, check out these YouTube videos.